The graph of a quadratic function x is equal to y square plus 2ay plus a square by 2 has the vertex at A and intersects the y-axis at the points B and C. If ABC is an equilateral triangle, what is the length of its sides? The diagram shows that the graph is a parabola with vertex at A and the y-intercepts are points B and C. The given equation is x is equal to y squared plus 2ay plus a square by 2. Now, how do you get the y-intercepts of this curve? Now, the y-intercept happens when x is equal to 0. Look at the diagram. When x is equal to 0, it is the y-axis. And the curve meets the y-axis at B and C. So if we equate x to 0 in the given equation, we will get an equation only in y, and that being a quadratic equation will give us two values of y, and those two values will be for B and C. The bigger value of y will be for C, and the smaller value of y will be for B. So let us proceed with the calculation. When you make x is equal to 0, we get y square plus 2ay plus a square by 2 is equal to 0. Now, on the left hand side, we add and subtract a square. Why do we do that? We do that to make this term a full square, and the other two terms are only in terms of a. Therefore, we get a plus a whole square is equal to a square minus a square by 2, and that is equal to a square by 2. Taking the square root on both sides, we get a plus a is equal to plus minus a by square root of 2. So this gives two values for y. One is y is equal to minus a multiplied by 1 minus 1 by square root of 2, and the other value is y is equal to minus a within bracket 1 plus 1 by root 2. These two values give the y-intercepts of the curve for B and C respectively. So, the coordinates of point B and C are, the x-coordinate is 0 for both of them. So, one coordinate is 0 and minus a multiplied by 1 minus 1 by square root of 2, which we just now found out. And for the other point, again the x-coordinate is 0 and the y-coordinate is the value we have just now found out, that is minus a multiplied by 1 plus 1 by square root of 2. And these are shown in the diagram. See that at C, x is equal to 0, y has some value. At B, x is equal to 0 and y has the other value. Therefore, the distance between B and C would be the differences of their coordinates, that is only the y coordinates, because for both B and C, the x coordinates are 0. So the distance CB is equal to y coordinate of C minus the y-coordinate of B. And if we put that into the equation, CB is equal to minus A plus A by square root of 2 plus A plus A by square root of 2, and that is equal to 2A divided by square root of 2, and that simplifies to square root of 2. Let us call it equation 1. This is the side length of the equilateral triangle ABC. It is given that the triangle ABC is an equilateral triangle. So we have found out the side length of the equilateral triangle following one method. Let AD be parallel to x-axis and therefore perpendicular to CB. Triangle ABC being equilateral, D is the midpoint of CB. D is the midpoint of BC. Now length of CD will be therefore half the length of BC, that is CB by 2, and that is equal to square root 2 multiplied by A divided by 2, and that is equal to A by square root of 2. Now let us find out the y-coordinate of D. How do you do that? We do that by taking the y-coordinate of C and we subtract from it the distance of CD. Then you get the y-coordinate of D. Remember, D is also on the y-axis, therefore its x-coordinate is 0. So you get y-coordinate of D is equal to y-coordinate of C minus A by square root 2, which is the length of CD, and that is equal to minus A multiplied by 1 minus 1 by square root of 2 minus A by square root of 2. And if we simplify that, that becomes minus A. Therefore, the coordinates of D are 0 and minus A. Now, we know that the triangle ABC is an equilateral triangle. Therefore, all the angles of this triangle are 60 degrees. So, we get the angle ACD, that is this angle, is equal to 60 degrees. Cosine of that angle, cos 60, we know from trigonometry it is half, and in this case it is CD divided by AC. We know the value of CD, which is A by square root of 2, and we do not know the value of AC, so we write AC. So from this equation, we get the value of AC as 2 multiplied by A by square root of 2, and that is equal to square root of A. Again, AC is a side length of the triangle ABC. We had already found out the distance BC, which is also the side length, and that was also root 2 by A, and this confirms that AC is equal to BC and the triangle is an equilateral triangle. Also, tan of 60, which we know from trigonometry is square root of 3, and which in this case is equal to AD by AC. Therefore, value of AD is equal to square root of 3 into CD, and we know the value of CD. Value of CD is, that is CD we have already found out, that is a by square root of 2. So therefore, AD is equal to square root of 3a divided by square root of 2. Let us call it equation 2. The y-coordinate of point A is equal to y-coordinate of point D, and that is equal to minus a. Why? Because we have drawn AD parallel to the x-axis. A is the curve. A is on the curve x is equal to y square plus 2ay plus a square. So at point A, x is equal to minus a whole square plus 2 multiplied by minus a plus a square by 2. What we have done here? We have put in the y-coordinate of A in this equation, and that is equal to minus a square plus a square by 2, and that is equal to minus a square by 2. Therefore, the x-coordinate of the point is equal to minus a square by 2. So what we have done here is, we have in the given equation this, we have put in the value of the point A, which is this, to get the x-coordinate of the point for at A. So the distance AD square is equal to a square by 2. Why a square by 2? The x-coordinate of this point is minus a square by 2. The x-coordinate of this point is 0. So this distance will be the difference between the two x-coordinates, and that is a square by 2. From equation 2 and 3, we get square root 3a divided by root 2 is equal to minus a square by 2. Therefore, square root 3a is equal to a square by root 2, or a square minus square root 6a is equal to 0. So we get a multiplied by a minus square root of 6 is equal to 0. This implies that either a is equal to 0 or a is equal to square root of 6. What we have done here? We have found out from equation 2 and 3, if you remember, we had found out the value of AD, the length of AD or the distance of AD, and following another method, we had found out again the same thing, the distance AD, and we have now equated both because it is the same distance to get the value of A. And because it is a quadratic equation, we are getting two values of A is equal to 0 or A is equal to square root of 6. But A cannot be 0 because then the side length of the triangle ABC, that is equal to square root of A, square root of 2 multiplied by A becomes 0, and the triangle collapses to a point at the origin. This can be seen from equation 1, that is the original equation. This will also be seen from the graph of the equation drawn on the next slide. Thus, the only value possible for A is square root of 6. So the side length of the triangle is equal to square root of 2 multiplied by A, and that is equal to square root of 12, and that is 2 square root of 3. This is the answer. But Go to the next slide to get more information about this. For better understanding of the problem, let us see what happens when a is equal to 0. The given equation is x is equal to y square plus 2ay plus a square by 2. When a is equal to 0, the equation becomes x is equal to y square. We know that this is a parabola symmetric about the x-axis. Its vertex A is at the origin and it opens out towards the positive x-axis. The y-intercepts of B and C are both 0. So all the 3 points A, B and C of the triangle ABC then collapse to a single point at the origin, that is 0, 0, 0. So this green graph is that of this equation x is equal to y square, and here this curve or this parabola touches the y-axis at only one point, that is 0, and the 3 points A, B and C therefore are all located at the point of origin, that is 0. When x is equal to square root of 6, the equation becomes x is equal to y square plus 2 square root of 6 plus 3. This is also another parabola, and the points A, B, C are distinct and separate from each other. And this parabola is shown by the red graph. You see that the point A is here, which is the vertex. Point B is here, which is one y-intercept, and point C is here, which is another y-intercept, and the triangle ABC is an equilateral triangle. Okay. The graphs for both these parabolas are shown. Thank you. Now, if you want to know about more problems of this type, please share this video amongst yourselves. Please subscribe and also like. Thank you.